All right, guys, here's our weekend edition of College Trig. Here we go. So we got to start looking at some of these common angles that we're going to see a lot in our special right triangle and trig and start seeing if we know what their sine, cosine, and tangent are equal to. The basis comes from this idea of special right triangles. So our two special right triangles we're going to look at is our 30, 60, 90. And our 45, 45, 90 in reference to the angles that make up those triangles. So if you recall, 30, 60, 90 triangle comes from an equilateral triangle cut in two. So let's assume that this equilateral triangle has side length 1. So when we cut this bottom half into 2, this side of the red triangle becomes 1/2. So in order to find this third side of our right triangle, we're going to go ahead and apply the Pythagorean theorem. So our hypotenuse is 1, so we have 1 squared is equal to 1/2 squared plus x squared. We'll call this side x. So we solve this. This is 1, which is equal to 1/4 plus x squared. If I solve for x squared, subtract 1/4 from both sides, I get x squared is equal to 3/4 square root both sides, and I get x is equal to the square root of 3. Square root of 4 is 2. So then I know that this now is square root of 3/2. And my angles here, because it was the equilateral triangle, I know this larger angle here is going to be 60 degrees. I have my 90-degree right triangle. It was a perpendicular bisector, and this is a 30-degree angle. So for our 45, 45, 90 comes from our right, a square, cutting a square in half, so we have right angles here. Splitting this angle here, we get 45 here, 45 here. Assuming that all side lengths are 1, this is 1, this is 1, and solving for the hypotenuse, we get 1 squared plus 1 squared equals the hypotenuse squared. So then we get 2 is equal to the hypotenuse squared. So our hypotenuse, taking the square root of both sides, is equal to the square root of 2. So we're going to use these two special right triangles to start building on this idea of a unit circle and what are those measures there for sine, cosine, and tangent. When looking at these special right triangles, dealing with the unit circle, we want to make sure our hypotenuse is 1. Well, for our 30, 60, 90 triangle, it worked out really well that our hypotenuse ended up being 1. Well, for our 45, 45, 90 triangle, our hypotenuse was the square root of 2, and these side lengths were 1. So what we want to do is we want to scale it down so that our hypotenuse is 1. So using some ideas of proportionality here and just rationalizing our denominator here, we can change this to, so using the idea of similarity here, I can go ahead and set up our proportion where my hypotenuse originally was the square root of 2 and my side length is 1. But now I want my hypotenuse to be 1. So what will that make my side lengths? So I cross multiply and I get x square roots of 2 is equal to 1. Solve for x, I get x is equal to 1 over the square root of 2. Don't want to rational number in my denominator, so I rationalize. And then what I'm going to get is x is equal to the square root of 2 over 2. So now that will define this 45, 45, 90 triangle as a hypotenuse of 1. And these are going to be the square root of 2 over 2 and square root of 2 over 2. So now let's build our unit circle off these two special right triangles. All right, now to build the unit circle, we're going to use these special right triangles to get some of these common measures from 30, 60, and 45. So notice our 30, 60, 30 triangle, when we have a radius of 1, fits into our unit circle here nicely. And we see that our x-coordinate here is going to be 1/2. And our y-coordinate is the square root of 3 over 2 when our angle is 60 degrees. So we can use that same triangle and flip it around, and we get our triangle with a 30-degree angle. And using those same proportions, move this out of the way for now, I can see that my x is going to be the square root of 3 over 2, and my y is going to be 1 over 2, just flipping those x and y coordinates, and we can see the similarity between our 60, 30, and 90 triangles. Moving these out of the way and giving room for our 45, 45, 90 triangle when we have a radius of 1, we can go ahead and put in there, and we can see our x and y coordinates here, with them being both the square root of 2 over 2. And this is going to be our foundation for our unit circle, where we can find our cosine and sine from these values for these three very important angles. Here being 45 degrees, this one here being our 30, and this one here being our 60. So to organize this a little bit more, I'll move these out of the way, and we can see that our angles here, the small one here is 30 degrees. The next one here was 45 degrees, and our next one was 60 degrees. And we'll show how this will be really useful here in the next slide. So now that we started building this unit circle, let's see how this is going to become useful for us. So let's assume that our theta is 30. If I want to find the sine of 30, and I want an exact answer, I don't want a decimal answer from my calculator, but I want an exact answer using radicals, I can use this. So sine of 30 is here, and these are my x and y axis. So remember that on the unit circle, my x corresponds to the cosine of theta, and my y corresponds to the sine of theta. These will directly tell me that my sine of theta is 1/2 for 30 degrees. Cosine of theta is the square root of 3 over 2. And to get my tangent, I just have to do sine over cosine. So I do 1/2 over square root of 3 over 2. When I multiply by the reciprocal, I get 1/2 times 2 over the square roots of 3. And then these cancel out, and I get 1 square root of 3. When I rationalize the denominator, I get square root of 3 over 3. So now I can go ahead and do the reciprocals fairly easy. 1 over 2. Secant is going to be 2 over 1. Secant of theta, or secant of 30 degrees, is 2 over the square root of 3. Rationalize, and I get 2 square roots of 3 over 3. And cotangent, well, I don't want to take the one with the rational on the numerator. I'm going to take, when it was on the denominator and I reciprocate it, I just get square root of 3 over 1, or square root of 3. So there you have the sine, cosine, tangent, and the 6 trig functions for 30 degrees. So for 40 degrees, we can use the same idea and look at sine of 40 degrees. There's my x and y coordinates, hence my cosine and sine. So cosine of theta, square root of 2 over 2. sine of theta, square root of 2 over 2. It's always nice with the sine and cosine of theta being 45 degrees because they're the same. So them being the same, we get a tangent that should have a ratio of 1 because they're the same. So if we do sine over cosine, they cancel out and we get 1. For cosecant, it's the inverse of sine, so we get 2 square roots of 2. Rationalize. And we get 2 square root of 2 over 2, which is equal to square root of 2. Well, secant's going to be the same. Square root of 2. Inverse of 1 is still 1 for cotangent. So now we can look at for 60 degrees now. So now we're going to use the x and y coordinates of that. So our theta is 60 degrees. So the sine of 60 degrees is our y value, square root of 3 over 2. Our cosines are x, 1 over 2. Tangent is sine over cosine, square root of 3 over 2. Multiplied by the reciprocal, 2 over 1, and we get square root of 3. Cosecant is going to be 2 over square roots of 3. Rationalize, and we get 2 square roots of 3 over 3. Secant comes from cosine, so we're going to have 2 over 1, or just 2. Cotangent is going to be 1 over the square root of 3, which is going to be square root of 3 over 3. There you have the first quadrant of our unit circle. In class on Monday, we'll start talking about quadrants 1, 2, 3, and 4 and talking about the symmetries, and we'll pretty much have the same values, but they're just going to be off by a negative or a positive sign. I hope you enjoyed this installment of Mathematics Trig on the weekends. See you on Monday.